I wanted to design a project for the 10 by 10 by 10 build volume featured on the small EasyThreed 3D printers, and I thought about a soap dish, or at least a soap holder, because it will fit into 10 by 10 by 10. So I'm going to go for the maximum size that will fit on the printer and see how that goes. I thought about this quite a bit. This is the result of the thinking. So I'm going to do this on Design Spark Mechanical. As you can see here in my open files, I have actually already designed the soap dish, but what I'm going to do is, instead of going to design it exactly as I have designed it there, I'm going to start again from scratch, so you can see all of the thought processes that go into it. And also this design was really, I can just open it so you can see this is my first one, as I say. I'm not going to do exactly the same again. I'm just going to open it. And you can see here what it is. So we need to use the spin tool to actually spin the design round here. And what I did actually, to make a grid on top which the soap sits on, and then a tray underneath to catch any drips. And I was trying to make it as easy to wash out as possible. And also another of my priorities was to actually make it without support material. So here you can see in the elements of it, you can see the top, the bottom and the leg. And I was going to copy the leg round to the other three corners. But it occurred to me then that it might be a wise idea to incorporate the leg or the separator in the bottom. And another reason for doing this is basically, to design it this way, is basically to reduce the amount of support material. When I design anything, I always think about support material, because when you make support material, it has two sides to it. It makes the supported side rough, and the supported sides of any surface is normally quite rough, and it's not very desirable. But the biggest problem with it is that it wastes filament, and you end up having to throw the filament away because it's no use for anything. So I always try and minimize it. So in this design, I'm going to make the top part separately and the bottom part separately, incorporating standoffs so that the top part will stand away from the bottom part. Then it will be cleanable. I was intending to use glue to actually fit the bottom part to the top part, so that although it would be preferable not to use glue, I think that glue will make it easier to make the top part and the bottom part more simple. So I'm going to go out of this now and start afresh. Just, if I do that, it will close it. So I'm just going to come back to the bottom here and say close that one. And it brings you to, when you first log into Design Spark Mechanical, it brings you to this screen, and it goes through the different versions of Design Spark Mechanical there are. I use the free version because it suits me, and also because it's free and it saves needless expenses. But some of you guys who may want to import STLs into your design so that you can actually build on what someone else has done, you can choose these other two subscription levels, which actually allow you to import STL. I tend to find though that I actually don't need STL at all, because very often when you do import an STL, it won't be quite right for what you need, and it's actually just quicker and easier to design it yourself from the ground up. And that really what I'm hoping to accomplish with these series of videos is to allow people to start designing things themselves. And very often when you actually start designing things, you may need to do something which I haven't covered or something, and then you can go looking for that on YouTube, or even think about it by trial and error, and achieve what you wanted to do yourself without asking anyone, without needing any help, by trial and error. And this software does lend itself to trial and error, and it doesn't punish you for trying things out, seeing what works, and going back if it didn't work, or it didn't work in the way you expected. As long as you make sure to save your design, which applies to any software when you're going through, as long as you always think to save your design as you're going along, then you can always, if something hasn't worked, you can always go back to the latest one that you saved. If you are using the software, I would save it regularly to a different file name, so that you have the stages as you're going through to refer to. That way you get the original file at an earlier stage. You can go back to it, and it could save quite a bit of effort. So we'll just go into File on the top left here, and then New and Design. And then you get a sketch plane here, which is shown in 3 dimensions. What you can do, if you go to Plan View, you can bring it up so it's right in front of you, and you're looking down. It's a top-down view. And these little squares are each a millimetre. So now we can start on a complete millimetre. The first thing to do would be to set a profile for the actual shape of the side of the rails of the top part of the soap dish. I was thinking that it might be advisable to set a kind of slope, so that the low 10 centimetres is probably a bit small for a soap dish. It's all we've got to play with from that printer. So we're going to say that the maximum size is 10 centimetres. You want the bar of soap to kind of sit in it. So it's kind of held in the volume by having a kind of a slope to it. So what I'm going to do is to do a 10, I think, yes, 10, 20 that is. So I'm going to do a 10 millimetre, rail. You can see that dimension. You can just type into those boxes and then do Tab to get to the next one, which is 10 again. So now it's a square 10 by 10 millimetres, and then I'm going to put a slope in, put a kind of a chamfer into it. Now we don't want the points of the chamfer to be too sharp, because otherwise the printer won't be able to print it and it'll end up being messy. So it's better to, I'm going to go from 2 millimetres on that side to 2 millimetres on that side. Actually, I'm going to maybe readjust that. You can always change this later. I think I might go to 1 millimetre to 1 millimetre. So I've created a line there, and then I'm going to delete the other lines that I've created. It's always a good idea to keep the model simple by deleting any lines that you don't need, and you use this tool here in the sketch tools to actually delete lines. You just have to highlight them here, and I've highlighted that one which I actually need, so I just do Control Z to get it back. Now I'm going to extrude that, or I'm going to pull that and make a 3-dimensional shape. I want 10 by 10, so I'm going to spin that using the spin tool, and then go back to the pull tool, and that 10 centimetres is going to be 100 millimetres, so I'm just going to go 100 with that. Type it in, press enter, and now I've got that shape, only it's now 10 centimetres long, and I want 4 of those. I want to duplicate this to create four of these. Control C, Control V, and you can see that it's generated another. Control V again and again to make 4 of the same things. They're actually occupying the same space now, but when I go to move them, you'll be able to see that they will move. So that the bottom one, the 4, is actually highlighted, so I'm going to move that away. I'm going to rotate it by 180 degrees. There we are. So that's now become the opposite of this one, and then I'm going to select the next one and move this one and only rotate it by 90 degrees. Oops, 90 degrees, and then using these arrows you can simply click on them. I'm moving that one so that it's roughly in the position. Obviously it's not lined up here, I'll have to do the lining up later. And now I'm going to choose that one, which is the top one, and then move, oh it's not right, Control Z, didn't really do that properly. So this one's that one, so that one's that one, this one's that one. Yeah, so what I'm going to do is to rotate that 300, I suppose that would be 270 degrees, and then move it up and then across. Now if you use the spin tool, you can see that the pieces of it have been created and moved, so you can see all 4 of them. And now I'm going to try to align them together. So we want this one. What I want to do is to make sure that this edge here and this edge here are together. What I might do is actually move them apart from one another a bit more, so that they don't overlap and accidentally become fused before they should be. So I'm going to move this way over here, this one, which is that one I think, to move it way over there. They should all be on the same plane though. They should all remain on the same plane. Oh no, no, that's not what happened. So yeah, I need to make sure too that they stay on the same plane. Otherwise it's confusing. Right, so if you rotate it round, you can see what axis or what plane of movement you should use to move it apart without changing the plane that all of the shapes are on. Now I'm just going to select that again and then do plan view, so that we get back to the plan view again. And I'm just going to move it into the middle again, into the middle of the screen again. I've not actually done this before when it comes to aligning shapes. I'm going to assume it will work. Okay, so now we've got these 2 shapes here, and what I want to do is to move this one. So it has this feature which is click an object to specify the destination which you want it to move, the selected object. I'm going to choose that, and then I'm going to do this. Oh, it did work, but it took it to there. I think that what I might do is try and move this. Oh no, I don't want to do that. So that whether I can move it to the end and then do this. So I want that to go there. Hopefully Now it will take it there. Yes, it's done it. So basically you have to move that move handle. This is what I actually mean about it being easy to do and undo, and also experiment and choose different things. So now when we choose this one, which is that one, I'm going to click here instead of clicking on the object. We need to use the move function, and we've got our handle here. If we move it to the end, there we are, it stayed this time. I think it changed. And then use this one and put it the line here. Yeah, it's done it. Now I'll just go around to the final piece and do that. That's this one. Back to the select tool, select this one, and I think, where is it? Oh, it's the second one down, that one. So then go to the move tool and then drag it to the end. There we are. It's done now on the end, and then go to, and then this one. There we are. I think that's right actually. Sure 100%, but yes, it is. And now we can zoom out and see the whole shape has been created. And it's very easy to actually align the different parts of it together using, instead of having to eyeball it or anything like that, you can do it exactly using the move tool. I'm just going to save this. I'm going to save as and do soap dish 2. And save that, and it saves it in this file format, which is the default format for this particular software. So I've got a copy like that. What you could do is just, actually I don't think I'll bother to name them, but you can, if you want to distinguish between the separate parts, you can actually just, I think I need to be in the select tool for that, so just select on the background, and then as you see you can type into the box, but I'm not going to bother to do that now. What I'm going to do is to combine the previous save. They are uncombined here. All you need to do to combine to make them into one shape is to use this command here, and what we'll do is normally just drag and select all the parts you want to combine together, and then just click on the combine. And now as you see, the 4 objects have disappeared and there's only one object. So that's what you want when you combine them. Now it's a single shape rather than 4 different components. And I'm just going to save again and say save as combined. Save. So now I've got the original separate one and the new one combined. So I'm just going to select that plane there and then put a sketch on it. You'll notice how when you choose a sketch plane that's within a model, somehow it automatically truncates the rest of the model, so that that's another useful feature I find with this software that it does that for you. So now you can do plan view, and it will go flat, and so you can see what you've got. And if I select this line here, it brings up the dimension of 80 millimeters. So I know how much we've got. That means we've got 80 millimeters to put our bars, I suppose. And we've got to arrange however many bars we want equidistantly in that 80 millimeters. I actually found a neat little piece of maths to help us organise things from ChatGPT, and I'm going to give you that little formula, so it might make it, I think, easy for you to arrange things in a space if you want to, so that they're equidistant. Now I used to just eyeball it, and obviously eyeballing things isn't an elegant solution. We know we've got 80 millimeters to play with, and we're going to want to put some bars in to keep the soap from falling through onto the bottom. So yeah, so basically that formula is gap size equals total length minus n times object width divided by n plus 1. So it's a bit of maths for you. We have 80 millimeters. What I did was I chose 5 millimeters for the bar size. N is the number of bars that you want to have. 80 millimeters, so that each of the gaps have to be 7.14. And as I say, I will put this up on the screen. So what you have to do is to make the bars. I'm going to put the spacing, and I'm not going to choose round bars because underneath the edge of the round bars won't be very well printed. So I'm going to put square bars, so that it'll all be completely flat on the bed of the printer. So what I normally do with this is put a line, and then to a line on the sketch. I'm going to put it 7.143, 7.143, and you will end up with a slightly different gap on the. Use the bar again to go 5 millimeters, and then 5 millimeters again, and then that's odd, isn't it? 4.5. It couldn't have been quite right, actually. It isn't right. You can see it's not right. Just going to go back and back and back by doing Control Z. So there should be a little. I think. So that's meant to be 7.143. 7.143. Yeah, and then do 5. And then 5 again. Five again. Oops. Five again. And then the next one, 7.143 again. 3. And then 5 again. And what's the difference when you get to the end? 7.14, so it's pretty much equidistant, and that's good enough for me, actually. So I've noticed the deliberate mistake. I should have started at the bottom here rather than starting there, but I'm just going to extend that line down, so I want it to be just yeah. I want yeah. There we are. You can see when you're going through that the software is trying to help you by giving you the angles and also snapping one line to the end of another and so on, so that it means that it helps you. As I say, I want everything to be flat on the build surface so that I think that's quite right actually. Seems to be slightly off. That's because it's snapping to grid. You have to be careful when you're doing lines that you expect to be continuous to make sure it does go from end to end. That's just that. So now I've got my, what I'll do is just use the pull tool. And as I say, when you go out of the sketch tool, you'll see that your well, just highlighting them all, holding down the control key, and then I'm going to pull so that they go all the way through to this side, and then they're going to become part of that. I have a feeling that they haven't completely fused with. Oh, that's interesting. Oh yeah, it does that sometimes. It follows the line of the above surface and then doesn't get you've got that problem that's going on there. I think I might just undo that for the time being, and then yeah, I'm going to just deselect those bottom surfaces. Yeah, so, and then go to the pull tool again. Just rotate it round with a spin, and then I'm just going to pull the top ones over, and not all of it, because that obviously didn't work. Certainly not really a problem. And then going to go and do exactly the same thing, and right, let's just get the select tool, and they haven't amalgamated with the sketch for some, with the model for some reason. What I'm going to do is probably now just extrude these edges down so that they line up with the bottom. That's probably the way I should have done it first. Now I'm going to just use the up to and choose the bottom. There we are. So I've achieved the same thing, and it has now amalgamated into one single piece. On the other side here you can see that it's only gone up to the face on this side, and then this side it hasn't. So again, with that, there's more than one way you can do that. Just select all these faces. This one. So I can just get the last one. Just control and just keep the control button. Oh, we've accidentally selected that one. Obviously you don't want that. So you can just, so what I'm going to do is just use that tool again and use that face. Now it's gone up to that face, and these 5mm bars. Actually, they're more than 5mm now. I think the gap was 1mm, so they should be 6mm. What we can do is to make them 5mm by just pulling again, pulling the other way. Again, it doesn't really matter whether they're 5mm. They could be 4mm. So we can choose there. I think I might make them 4mm, so we'll be reducing them 2mm. So then it doesn't waste so much material. So yeah, so you can see these are 4mm now. Yeah, I think you can use measure tool, or maybe not. You'd have to. Yeah, so yeah, you can see here the distance is 4mm. You have to click on one line and then click on another one, and then you'll get the distance between them. That might save a bit of trouble also. So now I'm going to just round the edges, and I'm going to select all of the edges and then use the pull tool to create a fillet and pull them instead of. We know they're 5mm apart. They're 5mm bars, so that you can choose 2.5mm for the distance to choose the pull. It defaults to the fillet already. You can see here in the options it automatically defaults to the fillet. So now I'm just going to pull that down. I think it's automatically chosen 2.5mm. So yeah, so now we've got those round bars and they go flat down to the bed surface, so there'll be no problems with overhangs or anything making it all appear nasty. That's going to form the basis for our soap dish, at least the top part. And the 4mm bars we have 1, 2, 3, 4, 5, 6 of them, and they're all equidistantly spaced with our formula that we learned from ChatGPT to help us arrange them. And so now I'm going to save that again. So I'm just going to save as soap dish top part, top part. Save. And if you did want to do away with the additional files that we created, you can just go in and delete them just by going into File Manager and deleting them. Obviously, if you leave them and if you change your mind about the design of this at a later time, if you looked at it and it's in use, you didn't like it, if you wanted to change it again, you could do so. If you leave the existing files in place, and then you can go right back to the beginning and without having to completely repeat everything. Anyway, I'll leave that for now. Thanks for watching, and I'll see you next time in my next video, which will be the second part of this thing, which will be designing the bottom part of the soap dish. Thanks very much. Bye.